Hey guys, I have your notes here for section 8.2 day 2. And what we're going to be doing is pretty much the same thing that you did in 8.2 day 1. We're finding areas between two curves. But it's going to get a little harder today because whereas yesterday you already had the graph, you knew your functions, you could very easily see where your upper and lower limits needed to be. All you're going to be given today is the equations of the two functions, and it's going to be up to you to graph it, figure out your intersections, figure out whether we're going to use vertical rectangles or horizontal rectangles, and then you're going to set up your integral and evaluate your integral by hand. So no calculators today. So here we go. The first thing I need to do is I'm going to graph my two functions. Everybody, I'm confident, should be able to graph that line. And with a quick reminder, everyone should be able to graph a simple parabola with some very slight transformations. So I think I've shown you this before in class, but I'm gonna do it again. Here's how I graph a parabola. I could make an XY table. Too much trouble, especially when I need to get through this quickly so that I can get onto the calculus of this problem. So here's how I graph a parabola. Normal. A normal parabola with no transformations. I put its vertex at the origin. So it's one of my 5 points. If I sub in 1 or -1 and I square it, I get a positive value of 1. So I have this point right here. I'm going to go out 1 either direction and up 1. And I'm going to make 2 points right here. So now I've got 3 points. I've got my vertex and these two. I'm going back to my vertex. If I sub in 2 or -2 and square it, I get 4. So I'm going to, from here, I've gone out 1, up 1, go back. Let's go out 2 each direction, up 4. 1, 2, 3, 4. Make your 2 dots. There you go. You've got 5 points to make a parabola. Well, this one's a little different, and you can see that I wrote it in more like a standard polynomial form. So this is a normal parabola that's been turned upside down, and the vertex has been moved up 2. So the first thing I would do is I would plot my vertex here. Then, from here, same concept except we're graphing it downwards. So from here, I'm going to go out 1, down 1. So you should make 2 dots right here. Go back to your vertex. Now I'm going to go out 2, down 4. 1, 2, 3, 4. Make 2 points down there. There you go. Quick parabola. And then, surely, I can count on you to be able to draw a line through the origin, negative slope, and this is the region that we're trying to find the area of. Okay. Now, let's decide, do we want vertical rectangles or do we want horizontal rectangles? Remember, when I draw my rectangles, I need to make sure that they go from one function to the other function every single time. So it has to go from blue to red, blue to red, blue to blue to red. It can never go blue to blue. So what I like to do is just draw a few segments that represent a rectangle. So let's say I had this super skinny rectangle that looked like that. Blue to red, we're good. Here's another, here's another, here's another. I just kind of draw them all the way through just to make sure that if this one segment represented a rectangle, a very skinny rectangle, it would go from blue to red, blue to red, blue. Okay, all the way through. So I need vertical rectangles. What we're going to do, we're going to create an integral that accumulates the areas of each rectangle. My width of each super skinny rectangle is going to be delta x, but in an integral that's dx, okay? My width is going to be delta x, and my height is going to be blue y value minus red y value. Blue y value minus red y value, and so on and so on and so on. we have to figure out the x where my accumulation starts. Add them all. We need to figure out the x where my accumulation ends. So that's where we've got to come over here and find the intersections. I think my intersections, of course, I'm not very good at drawing. I'm not very good at drawing accurate graphs. Maybe -1 and maybe 2. But here's what we're going to do. We're going to find the intersections. So we're going to kind of jump back to Algebra 1. Let's do some solving of our systems of equations. And you can see that they're both in y equals. So I set the two functions equal to each other. It's quadratic, set it equal to 0, factored it. Sure enough, my intersections were -1 and +2. So -1 is where our area accumulation starts. +2 is where our area accumulation ends. So now, didn't turn out quite as good as I hoped, but here I go. Now I'm ready to set up the integral. So start here, stop here. Remember, these are x values. It's very important. Now I've got my high function in terms of x minus my low function in terms of x. Remember, each blue, in each rectangle, the blue value is greater than the red value. So we want a positive height. Okay, dx, remember this is the height of my rectangle, this is the width of my rectangle, and this does area, height times width, over and over and over and over again, adds them all together. So I simplified it just a smidge, and then I went ahead and integrated, watch it, proper notation, subbed them in. Again, we're doing this by hand, no calculators. And then you've got some simple fractions to deal with, and I got 4.5. Feel free to pause the video and try that on your own and make sure you get 4.5. Next one. Same concept. We have a line and a parabola, only this time, a quick realization here for me, my y is being squared. This is going to be a sideways parabola. Again, I do expect you to be able to graph these by hand. They're simple. And of course, you can graph a line by hand. So let's work on the sideways parabola first. Normally, in a sideways parabola, if it's that is a normal sideways parabola. That's better. That's a normal sideways parabola. Normally, your vertex would be at the origin, and I would just tilt my head sideways and do the same thing. I would go out 1 in each direction and then up 1. And then I would go out 2 and up 4, because this opens toward positive x values. So let's graph the one here. So what it's opening toward the positive direction, and it's been moved back 4. The vertex has been moved back 4. So instead of having the vertex here, the vertex is going to be 1, 2, 3, 4 there. Okay? Easy. Ready? Out 1, up 1, make 2 points. Out 2, up 4, make 2 points. You've got this. It's easy. You should be thinking right now, good grief, I never realized graphing parabolas was that easy when I did it in Algebra 1. It's because it was new to you. Wow, my scales are terrible. Terrible. It's okay, whatever. Now, line y equals 2 minus x. So I've got a negative slope, and it has a, next slope is -1, y-intercept is +2. So here, 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 like that. There you go. That's the area we're trying to find. Now, watch what happens if I try to figure out vertical versus horizontal rectangles. If I draw a few, blue to red, it's looking good, looking good, looking good. I like vertical rectangles. Oh, shoot. That's not going to work. They end up going red to red. Okay, scratch that idea. Let's try horizontal rectangles. Blue to red, blue to red, blue to red. Yes. That's it. Horizontal rectangles. Now, horizontal rectangles. My accumulation of areas is going to start down here where they intersect at a low y value. And then we're going to start building our areas. We're going to add this area and add this area and add this area and add this area. And then we're going to stop up here at my highest y value. So now I'm going to check my intersections, and I need the y's of my intersections, not my x's. So the way the equations are set up, I'm going to solve this one for x first. And then, there we go. I'm going to solve that one for x first, and then I'll set each equation equal to each other. It's quadratic, set equal to 0, factor, and this time I've got my two y values. This is my low y where everything's going to start. I'm going to accumulate upwards until I get to here. I need to make sure, check out these rectangles. See this green rectangle? Isn't this blue x value greater than this corresponding red x value in this rectangle? Yeah. This x value is greater than this one. This x value is greater than this one. Make sure you do a positive height on your rectangles. You want your blue function minus the red function. We're doing right minus left. Every time we use horizontal rectangles, right minus left. So, low y, high y. These are y's. These are y's. These have to be y's. So, my blue function must be in terms of y. I couldn't write 2 minus x here. The blue function has to be in terms of y. The red function has to be in terms of y. And then this represents the width of each rectangle. It's a dy. Definitely would want to simplify this before doing an antiderivative on it. So I simplified it, put it in polynomial form the way you're used to it. Did my antiderivatives, use proper notation, sub them in, do the math without a calculator, and you should get 20 5/6. All right, practice that graphing, practice those sideways parabolas, practice those fractions. I know a lot of times I see you with calculators on your desk just because you're like, I just want to get through it. I know, I can't use a calculator on the test. I just want to get through it. Practice doing the fractions up here. Good luck, guys.